Over a quarter of the whale species in the world are critically endangered. And for the Brodus whale species, there's only 50 individuals left.
Every year, whales are struck by ships, caught in fish nets, driven away by noise pollution, and we have almost no way to track these things in real time.
Until now.
This is E.C.H.O.
Hi, I'm Abhi. This is E.C.H.O. It is a depth-adjustable hydrophone module. It is inside a custom-designed pressure-sealed ballast tank. We house an iPhone acting as our microphone and processing unit. The depth is fully adjustable, allowing us to detect all sorts of whale species at different depths.
So as our project grows, we will put hundreds of these into the ocean. Because of their size, but being motionless, no predators will pay attention to them because they are fish size. However, predators do not look for dead prey. They will be added with a solar panel, batteries, and a pump. This will allow the E.C.H.O. to come up when it needs to charge and then dive back down into the ocean by filling up a ballast in order to keep tracking whatever whale type it is tracking. This will be helpful because it will allow these to last much longer and for there to be absolutely no human interaction with the whales to make sure that they stay safe and become non-endangered.
We use an AI model trained on over 100,000 whale clips of just different whale audios, and this is able to classify over 10 different types of whales and their calling sounds. This is combined with triangulation that uses the difference in time between when we receive the sound of a whale on 3 or more microphones. This array can then be expanded into a larger network, which is able to set up no traveling zones or no fishing zones to protect endangered species of whales that we detect in certain areas.
I'm Nicholas. As you can see here, we have a proof of concept of our model. Here's a website built using Next.js and technologies like Tailwind CSS and React. What we do is we can have multiple recording devices, such as my phone here, and what it will do is when I press play and I give microphone access, it will use a WebSocket and pipe microphone data from this device to a localized server. This server will take all of the different microphone data, pipe it to a model in Python, and then use WebSockets again to display the data and results into this web UI interface. And this web UI interface will start updating with confidence readings based on the sounds that it's hearing. So if we have a whale sound, so you can see that it accurately was detecting that it was a humpback whale. And with this proof of concept, when we have three or more microphones, we can triangulate the signal of the sound or call of the whale, and then detect the species, and that's what we'll use to create those endangered regions.